Welcome to Operating System Week 4. This is Dr. Eliza. Process scheduling. In this week, we will be learn about process scheduling, types of scheduler, scheduling criteria, scheduling algorithms, multi-level queue and multi-level feedback queue, real-time scheduling. What is process scheduling? Process scheduling is activity of process manager that handle the processes. Which process to execute the CPU first and which has to be terminated. All these operations will be carried out by the process scheduler. So without scheduling, all the process will make the CPU to get, and we may get the system crash. So some manager need to regulate the execution of a process. So that manager is called a process scheduler. Scheduling is the process of organizing the processes. The importance of process scheduling, as I told, without process scheduling, system may hang or it may not use the CPU properly. So without scheduling, CPU time will be wasted, CPU resource will be wasted. So without wasting the resource, without wasting the CPU time, the scheduler allocates the schedules, processes to the CPU properly, as well as resources to the processes properly. There are different categories of scheduling based on the type, based on the way of context switch. We can classify the scheduling into two: non-preemptive, preemptive. It means if the process is running in the CPU, if higher priority process comes, the running process will be removed from the CPU. Such a scheduling is called preemptive scheduling. In non-preemptive case, once the process gets the CPU, nobody can remove the process from the CPU. Once a process completes its operation, then only the next process can get the CPU. Okay. So the process which is in the CPU cannot be preempted. That is non-preemptive scheduling. There are some queues, scheduling queues we call it as. Job queues, ready queue, waiting queue, and so on. The job queues keep all the process in the system. That is secondary storage memory. Ready queue contains the process that are ready to execute by the CPU. Mostly the space in the memory space is memory, main memory. Device queue, the process waiting for input output operation to be performed will be available in device queue. These are the three important scheduling queues. Verify your learnings. Newly created process will be kept in job queue or device queue or waiting queue or ready queue. The answer is ready queue. Newly created process will be kept in the ready queue for readily execute by the CPU. The resources cannot be removed from a process until the process completes its operation. In which type of scheduling? Non-preemptive scheduling. It cannot be removed. Next, what is process scheduler? Scheduler, as I told earlier, scheduler is a software which handles the process scheduling concepts. Their main task is to select the job and submit it to the system and decide which process to run next. There are three types of scheduler: long-term scheduler, short-term scheduler, medium-term scheduler. Long-term scheduler move the process from secondary storage to the main memory. That is from new to ready. Long-term scheduler is from moving secondary storage to main memory, that is ready queue. And short-term scheduler moves the process from ready queue to CPU. That is short-term scheduler. Medium-term scheduler move the process between one other than ready or running from one state to another. For example, the suspended ready process will be moved to ready using medium-term scheduler. Similarly, blocked suspended will be moved to wait using medium-term scheduler. So this only explained again in detail, so I don't want to waste much time. Long-term scheduler means job scheduler. Why it is take a long time? Because it takes too much time than the CPU scheduling, short-term scheduling. Why it takes too much time? Because it moves the data from secondary storage to main memory. Secondary storage is very slow compared to main memory. No. The second one is short-term scheduler. Sometimes we call it a CPU scheduler. The job is from move ready queue to CPU. Medium term scheduler in between the process, suspended to ready or blocked to wait and so on. That is medium term. Sometimes we call it a swapping. Swapping. Medium term scheduler is a part of swapping. Context switch. What do you mean by context switch? Moving a process from one queue to another queue. That is called context switch. Context switching is the mechanism of store and retrieve the state or process from one place to another place. For example, ready to CPU, ready to running, that is a context switch. Running to wait, that is another context switch. Running to wait or wait to running, context switch. So here you see we have process P1, P2, P3, P4. So whenever there is a context switch, the state will be stored in the systems, so that when it gets the next chance, it will be the status will be recovered from the stored places. Which of the following scheduler moves process from secondary storage to memory? Secondary storage to memory means long-term scheduler. Answer C, long-term scheduler. Which scheduler is called a swapping scheduler? Medium term scheduler is called swapping. Answer D, medium term scheduler. Now, CPU scheduling. We have many scheduling algorithms. These algorithms helps the process from moving from ready state to a CPU or running state, from ready queue to CPU. So scheduling is a process, move the process to the CPU from other states. There are some terminologies associated with this process scheduling. Arrival time. Arrival time means when the process arrive at the ready queue. That is arrival time. The time of process arrival at the ready queue. Burst time is the total time, execution time by the process. Burst time. Priority means priority of the process. Each process may assign priority. Gantt chart is the diagram which explains the execution of a process. There are some scheduling criteria. CPU scheduling, CPU utilization. Utilization means how much CPU is utilized. Throughput. How many number of processes executed at one unit time. That is throughput. Completion time. When the process completes its operation. Turnaround time. The total time of a process between the arrival and completion. That is turnaround time. So the time difference between the arrival of a process and completion of a process. That is turnaround time. Waiting time. How much time a process wait in the ready queue or in the waiting queue. The total waiting time of a process means turnaround time minus the burst time is waiting time. Response time. The first response time after arrival into the CPU. So after arrival into the ready queue, a process first arrive into the ready queue, and the time difference between arrival and the first response of CPU. There are some scheduling algorithms that we are going to learn now. They are all FCFS, shortest job first, priority scheduling, round robin, and multi-level queue, feedback queue scheduling. We'll learn all the scheduling algorithm one by one. Before that, we'll verify our learnings. Number of process completed per unit time is called throughput. Number of process completed per unit time, that is throughput. Time difference between the completion and arrival of a process. Time difference between completion and arrival, that is completion time. Answer A. So here it is mentioned as wrongly turnaround time. Sorry for the wrong answer. The answer for the time difference between the completion and arrival is not turnaround time. It is completion time. Sorry, that is turnaround time only. Completion and arrival, turnaround time. We'll discuss the scheduling algorithms one by one. The first scheduling algorithm is FCFS. What's the logic? The first process come to the CPU will get the CPU first. That's all. Very simple. Which process come to the CPU first, that will get you. See this example here. There are 5 processes, P1, P2, P3. Their arrival time is given as 0, 2, 3, 4, 5. It means P2 arrive at time 2. That's the meaning of it. Bus time means the total time needed for the process to complete. So at time 0 only P1 is available. So P1 get the CPU and complete its operations at the 6. Then P2. At time 6 all the process arrived. So at time 6 P2 gets a CPU because P2 comes to the ready queue next. Then P3, then P4, then P5. This diagram is called the Gantt chart. Okay. This algorithm is very simple. First is a process come into the ready queue will get the CPU first. This is another example for FCFS scheduling. Here you see the arrival time, the same example only. Only arrival time and bus time is given. Here using arrival and bus time we will calculate the completion time. Completion time means when the process completes the operation. The completion time of P1 is 6, P2 is 8, 9, 18, 26. That is completion time. Turnaround time, completion minus arrival. That is 6 minus 0, 6. 8 minus 2, 6. 9 minus 3, 6. 18 minus 4, 14. And so on. Waiting time, no? Total turnaround time minus bus time. That is waiting time. Okay. So we subtracted T8, we subtract the bus time from TAT. That is waiting time. 6 minus 6, 0. 6 minus 2, 4. Sorry. Total turnaround time, waiting time means total time minus bus time. That is waste time. 6 minus 6, 0. 6 minus 2. Actually, it has to print 2. Because the total, it arrives at time 2. It completes at time 8. So how much time it waits? It arrives at time 2. Its bus time is only 2. But it completes at 8. So the waiting time is the turnaround time is 6. Arrival time is 2. So 4 unit time it waits. So there is a mistake here. The value will be 4. 6 minus 1, 5 and so on. And if we perform the average completion time, now we have to add all these things and divide it by the number of processes. We will get average completion time, average turnaround time and average waiting time. Convoy effect is one of the problem in FCFS scheduling. So FCFS assures that other process only gets CPU time when the current one is finished. So in FCFS, all processes are waiting for one long process to finish. Suppose in a single road where the car cannot overtake. Suppose if a longer vehicle move on a road, all the small cars or bikes, everything has to be follow the long vehicle. Likewise, lot of small process has to wait for one long process to complete. This problem is called the convoy effect. This is one of the problem in FCFS scheduling. Verify your learnings. In FCFS scheduling, what are the two values will be equal if the process has arrived at time 0? Suppose all the process arrived at time 0, which are the two values will be equal? Completion time and turnaround time. Which of the following statement is wrong with respect to convoy effect? Resource utilization will be less. Yes, that is correct. Shorter process will be waiting for a long process to finish. Yes, this is correct. FCFS always suffered by convoy effect. We can't say always. So the answer is C. The next scheduling algorithm is SJF. shortest job first scheduling. So here from the word itself it is very clear, among the process available in the ready queue, which process has shortest burst time, that process will get the CPU first. That's all. So see this example here. At time 0, the process P4 arrived. So P4 will get the CPU and execute for 3 unit time. And in SJF there are two categories. One is non-preemptive, another one is preemptive. In non-preemptive case, once a process gets a CPU, other process cannot preempt. So at time 0, P4 arrived, so it executes for 3 unit time. At time 3, process P3 arrived, process P1 arrived. Among P3 and P1, which one is smaller? P1 is smaller because P1 is 6. So P1 execute next. Then at time 9, all the process has arrived. P1 and P4. P2 and P5. Among P2, P3, P5. Among P2, P3, P5. P2 is smaller. So P2 executes. Then P5 executes. Then P3 executes. Based on the burst time, the process will be executed. So at the particular time, what are the processes available in the ready queue? Among the available ready queue process, which is shortest job, that will be executed first. In this case, if the shortest job arrived later, it will not preempt the executing process. That is non-preemptive case. Okay. Similar to FCFS, we can calculate the completion time, turnaround time, waiting time, and so on. And this is the average waiting time case. Okay. In case of preemptive SJF, what happened? Here you see, at time 3, P4 completes its operation. At time 4, P5 comes. P1 gets a CPU whose burst time is 6. But at time 4, P5 comes, which is smaller than P1. P1 is 6, P5 is 4. So P5 is smaller than P1. So what happened? The P5 preempt the P1 and P5 get the CPU. That's why it is called preemptive SJF. Please excuse for the heading. SJF preemptive. Okay, this is preemptive case, not non-preemptive. This is preemptive case. Okay. So completion time, turnaround time, and waiting time, that can be calculated very similar to the preemptive SJF. Advantage of SJF: maximum throughput, minimum average time. Verify your learnings. SJF scheduling has minimum waiting time. SJF longer process may wait for a long time, or they may not get the CPU. The problem is called starvation. If depends upon the size, longer process has to wait a long time. That is called starvation. Third one is priority scheduling. In this case, the highest priority jobs gets the CPU first. Here you see the example. There are, for every process there are some priority. So here lower number indicates higher priority. It means P2 is a lower priority case. But at time 0, only P1 is available, so P1 gets a CPU. Okay. Here also in priority scheduling, we have non-preemptive priority and preemptive priority. This case non-preemptive priority, that's why P1 completes its operation and then only P2 comes. P2 gets the CPU. P2 smallest priority. Then P4, the next smallest. Then P3, fourth smallest. Then P5, least. Calculate the completion time, turnaround time, waiting time, and so on. Non-preemptive. Similarly, preemptive priority scheduling. In this case, you see P1 gets a CPU initially, but at time 2, P4, the smallest priority scheduling, highest priority schedule process comes, so it preempts. P4 gets a CPU. At time 5, the highest priority preempt P4 and gets a CPU. This is preemptive priority scheduling. Similarly, we can calculate. So in this priority scheduling, the advantage is the important process can get the CPU quickly. Starvation problem is again gets here. So starvation problem we get. What do you mean by starvation? The lowest priority job has to wait for a long time. Sometimes it may not get the CPU. So the problem can be solved by aging. Aging means we can increase the priority of the lower priority job in every cycle by one. So at any cost, at a particular time, the lowest priority jobs will get highest priority. Which process will execute at next if two processes are having the same priority? FCFS will be followed. Answer C. What is the solution of starvation? The solution is aging. Aging means we are adding the priority one by one on every cycle. Round robin scheduling is another scheduling algorithm. Here, the CPU is assigned to each process with a fixed amount of time. So, irrespective of their burst time, every process will get equal priority. So, based on the time quantum, every process will execute. For example, if time quantum is 3 means, every process will execute 3 unit time. Whether it completes or not, it will give a CPU for the next process. See here, the time quantum is 2. It means first process will get 2 unit time, second process will get 2 unit time, third process will get 2 unit time. Here the third process P3 complete its operation within 1 unit time, so it next process gets on 5. So it will get a maximum of 2 unit time because the time quantum is 2. That is round robin scheduling. Similar to previous scheduling, here we can calculate completion time, turnaround time and waiting time. Similarly, average times. So depend upon this time quantum. Suppose if we increase the time quantum, it will be equal to FCFS. Suppose the time quantum is very big, it will be equal to FCFS. If time quantum is very small, what's the problem? The context switch will be more. So it will take more time for context switch than execution. So it depends on the time quantum. The round robin performance will be either better or worst. That only explained here as advantage and disadvantages. So round robin scheduling is always preemptive nature. If we increase the value of time quantum, round robin scheduling tends to become FCFS. Suppose the time quantum is very big, time quantum is 100, then obviously it will be equal to FCFS. Multi-level queue scheduling means there will be multiple queues. Okay, the process will be, system process will be stored in system queue, interactive process will be stored in interactive queue, batch process will be stored in batch queue. System process will have higher priority. So all the processes in the system process in this queue, first queue will be executed first, then the process in the second queue will be executed, then the process in the third queue will be. So multiple level of queues will be there in this case. So which queue can be given higher priority among the following queue in MLQ? Usually system process queues will have a higher priority. Which of the following is the advantage of multi-level queue scheduling? In multiple queue scheduling, maximum resource utility is one of the advantage. What is multi-level feedback queue scheduling? In multi-level feedback queue scheduling, each and every queue will be moved to the next queue with the higher quantum. For example, the process executed in time quantum 8 will be moved to quantum 16 and finally it will move to FCFS. So every time the process will be moved from one queue to another queue. So if it is not able to execute in quantum 8, it will move to quantum 16, time quantum 16. If it is not able to finish its operation in quantum 16, it will move to FCFS. Real-time scheduling is the last topic in this week. That is, real-time scheduling or system carries real-time task. Real-time task can be classified as hard real-time tasks and soft real-time tasks. Hard real-time tasks we already discussed. It means it has to follow strictly on time. Soft real-time can miss the time, but it has to complete. Real-time system schedulers is considered most important. So for hard real-time task, we have to choose this algorithm based on this scalability, schedulability. So state table driven approaches, state priority driven preemptive approaches, dynamic planning based approaches, dynamic best effort approach. These are the various approaches used for real-time scheduling algorithm. Which of the following scheduling algorithm is free from starvation? The answer is multi-level feedback. Starvation won't come because it will be moved from a lower time quantum to higher time quantum. Dash scheduling, task must be performed at a specified time, which could otherwise lead to bug. It means the hard real time. That's the answer for this question. So in this week we learned about process scheduling, types of scheduling criteria, and all the scheduling algorithms we learned from this week. Thank you.